Hi and welcome to today's session on internal angles in polygons. So when we've got a polygon which is made up of straight sides, and there are no breaks within the lines, creating a region on the inside, of course that is a polygon. But where each of our edges are meeting to create a vertex, that is the angles that we are looking to calculate. Polygons have got internal angles and external angles, but we're going to look at external angles on a separate clip. So here I've got a triangle, and we're going to use the facts of angles in a triangle to calculate angles in polygons. So here I've got my angles A, B, and C within my triangle. We know that these add up to 180 degrees, and we can actually prove that these add up to 180 degrees. So here's my triangle. If I was to draw a parallel line to the vertex, higher vertex of this triangle, which is parallel to the base, what we can see here is that using alternate angles, so using our Z angles, this angle here will be equal to this angle here. This angle here will be equivalent to this angle here. So here I've got angles A, B, C, and angles on a straight line add up to 180 degrees. So all these three angles added together, 180 degrees, which proves that this angle will be the same as this will be the same as this will stay the same. So angles in a triangle have got to be the exact same as angles on a straight line, equaling 180 degrees. So when we are looking at regular polygons, here we've got an equilateral triangle, and we've got to calculate angle A. We've got 180 degrees. Three angles are exactly the same within an equilateral triangle. So if we divide 180 by 3, that will give us our angle A of 60. So we are using the definition of the internal total angles within the triangle to find the missing angle. For an isosceles, here we've got our isosceles triangle, where the definition of an isosceles, the base angles at the base of the triangle are equal. We've been given the angle of 88 degrees for the one angle. To calculate A, we know that the angles at the base are equal. So if we take the 88 away from 180 and then halve this will give us the size of just one of these angles, which is 46 degrees. As you can see, I've done the full working out algebraically, but of course, if you wanted to take a step and jump straight through, showing you working out, you're more than happy to. So we're going to use the definition of the triangle to calculate internal angles in polygons. So here we've got a quadrilateral. Remembering a quadrilateral has got four sides, and now if we was to take our quadrilateral and join to the opposing vertices with a straight line to the corners by a straight line, we've created two triangles. We know that triangles have got 180 degrees angles within the triangle. We've got two lots of these, so if we double the 180, we know that the sum of the angles within a quadrilateral four-sided shape has got to be 360 degrees. And of course, we can use this definition for all different types of polygons, several-sided polygons. So here we've got a pentagon. Now, the sum of the internal angles is 540 degrees. We can prove this by splitting it into three triangles. So easiest way that I do this, I pick one point and then I draw lines out to the corners until I can't do it anymore to create triangles, but I only do it from one single point. So each one of these triangles is 180 degrees. Multiplying that by 3, that tells me that the sum of the angles in this pentagon, five-sided shape, has got to be 540 degrees. Now, here I am breaking things up into various parts by using a formula to actually calculate the sum of the interior angles. But what I've actually used here is n minus 2, multiplying that by 180, that will give me the sum of the interior angles, where n is the number of sides of the polygon. So using my octagon, now if I was to use my method beforehand, this splits up into 6 triangles. So if I was to multiply 6 by 180, that would give me 1080 degrees as a total. But using the formula, n minus 2, so 8 sides minus 2, that gives me 6. So, which is the exact same number as the amount of triangles. 6 times 180, as we just said, the total sum of internal angles will be 1080 degrees. Now, if we are told that this is a regular polygon, so all sides and all angles are equal, we could actually calculate a single interior angle for this shape by simply dividing it by how many angles there are within the shape. So 1080 divided that by 8, a single angle within our octagon is 135 degrees. And of course we can use this to find other sided shapes also. So a triangle, a single angle, a regular triangle or an equilateral triangle will be 60. We know that a square will be 90. A pentagon will be 108 and a hexagon will be 120. If you like what you see, please subscribe. Thank you very much for watching.